Welcome viewers to Gateway Learning Center. Today we're looking at physics and radioactivity. So under radioactivity, we'll focus on how to write radioactive decay equations. So radioactive decay, we're looking at how the nucleus or the nuclei of an atom, the nuclei of a substance disintegrates or splits. That's a simple English you can use. So whenever the radioactive substance emits radiation, to emit, we are saying, is to take out, then to decompose is same as to decay. So here talking about decompose. Then radiation, we have three types of radiations. We have alpha radiation, then we have beta, and last we have talk about gamma. So whenever a radioactive substance emits a radiation, we mean gamma, we mean alpha, and we mean beta. So these are three types of radiation which we are looking at. So this means that any substance, it has what you call a nucleus. Now, this nucleus, once it emits these types of radiation, we are saying that this nucleus has disintegrate. So radioactive decay, we are saying, is the disintegration of a nucleus due to alpha, beta, and gamma radiation. Radioactive decay, the definition you can give here, radioactive decay, we are saying, is the disintegration of a nucleus due to alpha, beta, and gamma radiation. That's what you call the radioactive decay. Then apart from that, we need to understand that when the isotopes of either alpha or beta particle emitted, the parent, so when these two are emitted, the parent nucleus changes. So the process by which this parent nucleus will change, process which is involved in this type, we are saying that it is called transmutation. The process is called transmutation. Okay, so this is what we are looking at. So all in all, what we are saying is that radioactive decay is the disintegration of a nucleus or nuclei plural due to alpha, beta, and gamma process. Then to disintegrate is same as to split in order for this nucleus or nuclei to become stable. The type of radiation, we have beta, alpha, and gamma. Now the good part is that when gamma radiation is being produced, it does not change the parent nucleus. The nature of the parent nucleus does not change because gamma has been emitted. Of course, we'll find that there will be changes in temperature, in energy, but in terms of the mass number and the proton number will not change. So that is about the radioactive decay. Now, we have talked about 3 types of radiation. Let's start looking at each type of radiation. So we'll start with alpha. So let me create a space here. All right, so let's talk about alpha decay. During this type of decay, we are saying that when an atom decays by emitting alpha, so when this atom decay by emitting alpha, what happens? This atom, it moves 2 steps backwards. It moves 2 steps backwards on the periodic table. If this happens, we are going to understand that mass number is reduced by 4, then atomic number is reduced by 2. So now from here, okay, by 2. So what we are saying is that whenever a new substance is being produced after the disintegration, we are going to discover that that new substance which will be produced, its mass number will have a difference of 4 and its atomic number will have a difference of 2. So the one which has produced a new atom or element is called, we have a parent. The parent nuclide. So this parent nuclide, we are saying it is the one which is producing now what we call a daughter nuclide. So the parent produces a daughter nuclide due to the integration of the alpha. Apart from that, we need now to understand how to write the alpha decay equation. So the alpha decay equation, from what we have written, we can now see that alpha particle is co-helium particle. All right, so the decay equation my space here cannot allow me to write what I want to write, so let me move this part. Okay, so with that background, we can now talk about the decay equation. So decay equation, we'll say now, if we have an element, let's say we have X, then there's mass number and atomic number, then this element which we have, we'll say now A minus 4, then Z minus 2, then it will give us another new element which is called now the daughter, then plus 4, 2, then we put helium particle. So every alpha decay is being represented by this helium particle. So alpha decay, you're looking at helium particle. Remember, we said that when a new equation or when a new element is formed, always it will differ by 4 from the mass number, then by 2 from its atomic number, the one that's been produced. So this is the equation which can help us to understand about the alpha decay equation. Then again we said, whenever an alpha decay takes place, whenever a nucleus of a certain element emits an alpha particle, it means that that one as a daughter nuclide which will be produced will differ mass number by 4, atomic number by 2. So this is the illustration we are looking at here. Let's say we have aluminium. For the sake of trying, we have aluminium. So aluminium, Al, there's a mass number of 27, the atomic number of 13. So if aluminium element emits an alpha particle, what is the name of or what's the mass number and the atomic number of the new daughter nuclide? So it will be now 27 minus 4, then 13 minus 2, then we don't know what will be produced here, plus helium, so 4, 2. So this part is telling us to say we have used alpha decay. So our final answer can be 27, 13 of this aluminium, then 27, we take out 4, we remain with 23, then 13 take out 2, 11. Then from here, we'll say which element has the mass number of 11 and the atomic number of, which element has the mass number of 23 and atomic number of 11, so that is sodium, then plus 4, then 2, then we put helium here. So this is our new equation. So sodium is the daughter cell which has been produced, or the daughter nuclide which has been produced from the parent aluminium. So what has happened is that we have removed 4 from the mass number of aluminium to get 23. Again, from its atomic number, we have removed 3. So this means that aluminium has moved 2 steps backward on the periodic table. If the question was what is the mass number of the daughter nuclide, so its mass number now will be 23 and its atomic number will be 11. So this is about the alpha decay equation. So from here, we'll look at one question from the exam, then we see how this part can be applicable in an exam. All right, so this is the question which we have before us. So the symbol 238, which is the mass number, and 92, which is the atomic number, with this symbol represents a nucleus of uranium with nucleon of 238 and the proton of 92. First question, state the meaning of nucleus of nucleon number. We need to know that this nucleon number is same as mass number. There's no difference. So for us to know the mass number, we need to know that formula in chemistry, which we say atomic number or mass number or nuclear number is equal to proton number, then we add the number of neutrons. So for us to have this one, we need to add proton number and the number of neutrons. So having known this now, we can say nuclear number now so nuclear number is the sum of proton number and neutron number in an atom of an element. So proton number and neutron number, when we add this and this, we are going to get the mass number. So that's the first part, which had 1 mark. Then the next one, B, a nucleus of uranium-238 decays to form a nucleus of thorium. So they have given us the product which will come out after this uranium has undergone decay by emitting an alpha particle. So this one was very simple because they have told you to say once nucleus in the uranium decays, it will give us thorium. Then when it decays, it will produce or it will emit a radiation which is an alpha particle. Therefore, when that has happened, can you state the proton number of an alpha particle? So remember, the proton number of an alpha particle is what we discussed on in the preamble of this video. Therefore, we'll say, let me remove this part. I hope you have copied the question. You can also check the same question, I think in the 2019 past paper from section B. Okay, so for us to know now the mass number, we can answer the equation, then we can just be getting the values from the data we're going to collect. So uranium 238 92 will decay. Since we have 238, then we have 92, we said the mass number will reduce by 4, then the atomic number by 2. So they have said thorium will be produced. So we know the symbol for thorium is this one, then plus the iridium particle, which is the alpha particle, like that. So when this happens, we know that from 238, we're going to take out 4. So thorium will give us something like 234 to give us 234, then and 90. So this is our new daughter nuclide of thorium. This is now thorium. Then this part here is called helium. So we have thorium and we have helium there. Hope you're able to see. Then you can come back to our questions and say the first one, state the proton number of an alpha particle. So an alpha particle is this one. Then proton number is this number. So the proton number is 2, as simple as that. Then the nucleon number of an alpha particle, nucleon number is same as the mass number, so this part, so just put 4. What else? Proton number of thorium. So thorium we have already calculated, so the proton number will give us 90, this number here. Then the nuclear number of thorium, which is also the mass number, so we have 234. So we have 234 here. So this is what the question was demanding us to do, and this is how we can apply the alpha decay. So always, whenever we are solving this type of questions, we need to put in mind and to bear to say, when they mention the type of radiation, will guide us how to come up with the mass number and the proton number. Next time, we'll look at how to answer the same type of questions now when the beta particle has been emitted, so that we can try to compare how to come up with the answers with different questions. So for today, we end here. We can go and search for other questions which can help us to apply the alpha decay.